Good morning, students. This is the solution video for the MJ 2019 paper 4-3. As usual, please refer to the timestamps available in the description below for specific questions, and you may pause the video to copy down any working as I'll be showing the solutions to the questions continuously. So without further ado, let's begin. So starting off from our first question. So our first question, we are given a train timetable from London to Marseille. So from London to Marseille, all the times given are in local time. So when they say this, they are referring to the local time of that particular area. So there's the local time in London, local time in Ashford, Lyon, Avignon, and Marseille. So the local time in Marseille is 1 hour ahead of the local time in London. In other words, this is Marseille time, right? So technically speaking, for London time, Marseille is actually 13:46, right? So by keeping this in mind, we can now answer A1, work out the total journey time from London to Marseille. So in reality, it only takes, according to London time, it is 7:19 a.m. to 13:46 p.m. So from here, we do 13:46 minus 7:19. So when we are subtracting time, it would be good to split between the hours and minutes because it doesn't work like a normal subtraction. So from here, 46 minus 19, this will be borrowing a 6, borrowing a 10. So that'll be 16 minus 9, that will be 7. So 3 minus 1 is 2. And this is 13 minus 7, and that's will be 6. So this is 6 hours and 27 minutes in this case. So that's for our question A1. So the distance from London to Ashford in part A2 is 90 kilometers. The local time in London is the same as the local time Ashford, so we don't have to worry about it. So work out the average speed in kilometer per hour of the train between London and Ashford. So first we look for the time taken. So for the time taken, it is basically the same type of calculation. We're going to take 0755 minus 0719. So from here, we're going to split between the hour and minute. So this will give us 36 minutes and 0 hours. So if you notice, the unit is in kilometer per hour, so we must convert our 36 minutes to hours. So 36 minutes is basically 36 over 60 hours. Or in other words, it would be 3 over 5 hours. So therefore, our average speed in this case would simply be distance over time. Our distance is 90 and our hours is 3 over 5. So from here, that would be 150 kilometers per hour. So moving on to question 2, part 3. So during the journey, let me just grab the question. So in part 3, during the journey, the train takes 35 seconds to completely cross a bridge. The average speed of the train during this crossing is 90 kilometers per hour. The length of the train is 95 meters. And calculate the length in meters of the bridge. So in other words, what we're going to look at is that we need to look at the perspective of the bridge and the train. Now, this is point in which we are going to pretend that this one is like the cliff and this is the bridge, right? So the bridge has a length of x, right? Let's just pretend that it's x here, right? And then this is the other side of the cliff. Now, to work further into the question, we are assuming the starting point of the train in this case. We are pretending that the train starts from somewhere around here, right? Right at the beginning of the bridge here. So the train is 95 meters long. This 95 meters. Now, we are assuming that the bridge is longer than the train. So as the train continues to travel through, right, we need to consider how much distance does it travel in the first place. So 35 seconds and 90 kilometers per hour, right, we can actually calculate how much distance the train travels. So we need to convert the units first. So 90 kilometers per hour or speed equals distance over time again. So 90 kilometers per hour equals to distance over time. The time is, in this case, 35 seconds. So we need to convert our time into hours. So 35 seconds is simply 35 over 60 minutes, or divide by 60 again, that will be 35 over 3,600 hours. So we're going to plug this value in here. So it will be 35D over 35 over 3,600. So D is simply going to be, we're going to take 90 multiplied by that fraction. So that would be 0.875. Take note that this is in kilometers. So converting it back into meters is 870 meters. So what has essentially happened is that the train is traveling for 875 meters, then it successfully crossed the bridge. Now, for it to successfully cross the bridge, it means that every single part of the train has to pass the bridge. In other words, the train has to fully get past, as in 95 meters of the train has to get past as well. So this 875 here is both the bridge and the train combined together. So we need to do some subtraction here. So therefore, the length of the bridge in this case would simply be 875 subtracted with 95 because there is an additional 95 meters that the train needs to travel to complete its full length. So in this case, 875 minus 95 will give us 780 meters. So that is the length of the bridge. So that is for question 3. So moving on to the next one. So we have a couple of questions for the train fare. So as for the train fare itself, so we have fares for the train journey are shown below: adult standard and premier fare, child standard, premier fare. So right for the standard fare, write the ratio of the adult to child. So we're looking at just the standard in this case. So adult to child is 84 ratio 60, and then we can simplify the fraction further. So both numbers can divide by 12 from the looks of it. So divide by 12 here, divide by 12 here. So that will be 7 ratio 5. So that's quick calculation. So in part 2, for an adult, find the percentage increase in the cost of the standard fare to the premier fare. So adult increasing from standard to premier, this is a percentage increase equation. So for percentage increase, we will take the new minus the old, divide by the old, multiply by 100 in this case. So the new minus the old, the new is the 140. We pretend the new fare is the higher fare, the premier fare. So 180 minus 84, whole thing divide 84, multiply by 100. So that would be 66.67% increase. Yeah. Or in other words, 66.7% increase to be in three significant figures. Right. So this is in part 2. So for part 3, I will repaste it because it's actually longer than that. So in part 3, it is given that for one journey from London to Marseille, the ratio number of adults to number of children is 11 to 2. There were 220 adults in this total on this journey. All of the children and 70% of the adults paid the standard fare. The remaining adults paid the premier fare. Calculate the total of the fares paid by the adult and children. So we need to consider our calculations here. So we know that if, according to the ratio, 11 parts is equals to 220 adults. So from here, 1 part is equals to 20 adults. So 2 parts is equals to 2 multiplied by 20 would simply be 40. So there's going to be 40 children. Or I shouldn't say adult and children, I should say 40 people, right? To be more to be more generalized in this case. So this is people, right? Now, since we know the number of people are working out already, so we have adults. 70% of them pay the standard fare. So we want to count the standard fare for adults. That would be 70 over 100 multiplied by 220. So 70 over 100 multiplied by 220 would simply be 154 adults. Whereas the ones that paid for the premier is the leftover. So that's 220 minus 154. So 220 minus 154 would be 66 adults. Whereas for the children, it is just precisely all the children paid the standard fare. So all the children take standard. So that would just be all children standard is 40 children. Right? And then from here, after we calculate the number of people already, we can now use back our table to calculate a value. So adult standard fare is $84. So it's 154 multiplied by 84 plus by, so 140 the premier, so 140 multiplied by 66. And then from children, 40 multiplied by 60. And then we can total up the value here. So 154 times 84. This one, the rest is calculator work. So you may use your calculator to get the answer quickly. So that would be a total of $24576. This is the amount of fares paid by the adults and children. Right. So in question C, there were 3.08 times 10 to the power of 5 passengers that made this journey in 2018. This was a 12% decrease in the number of passengers that made this journey in 2017. Find the number of passengers that made this journey in 2017. So from here, 3.08, this is a drop. So we are looking at the 88% is 3.78 times 10 to the power of 5, right? So 100%, we are looking for this, right? So all we need to do is just reverse the calculation, right? So in this case, to reverse our calculation, all we need to do is just find the 1%. So 1% is 3.08 times 10 to the power of 5 divided by 88. So 1% would simply be 3,500. And then from there, we multiply by 100 to get our 100%, which is the original amount. So 100% would simply be 3,500 times 100. So that is 3.5 times 10 to the power of 5. Or if you want to do a faster calculation, all we need to do is 3.08 times 10 to the power of 5 divided by the percentage multiplier, which is 0.88. So we will also get 3.5 times 10 to the power of 5. Both workings are acceptable, but use the one that you're more comfortable with. So for number 2A, 5x minus 17 equals to 7x plus 3. So 5x minus 17 equals to 7x plus 3. So negative 2x minus 17 equals to 3. So negative 2x equals to minus 7x on both sides. So we will get, oh, sorry, this is minus 7 on both sides, add 17 on both sides. And then from here, this will be negative 2x equals to 20. So x equals to negative 10. So that is solved. So find the integers values that to satisfy this inequality. So to solve for our n first in part B, we need to divide everything by 4. So ultimately, our inequality will be negative 7 over 4 less than n less than equals to 2. Now, this value, you can type it down in decimals first to work with. This is actually negative 1.75 n and 2. So in other words, our integer values will take negative 1, 0, 1, and 2. So we are assuming that 0 is integer, lah, right? But normally 0 is not really an integer in proper definition. But in this case, we include 0. 0 is part of the answer scheme like this. So we just put it just in case, lah. At least for the IG level. For higher levels, we don't consider 0 to be integer. So in C part 1, a to the power of 3 times a to the power of 6 is a to the power of 3 plus 6, which is a to the power of 9. 5xy squared to the power of 3. So that would be 5 power 3, x power 3, y power 6 as we multiply all of the individual powers together. And then we simplify to 125 x power 3, y to the power of 6. So that's our final answer. So in part 3, from here, we will check our calculation. So again, this is another power on power question. So we're going to multiply all the powers in. If you would like to get rid of the negative first, you may. There is a negative here, yeah, in case you didn't see. It's also pretty hard for me to see, but it's very unnatural for there to be a very long fraction line, so I assume that to be negative. So from here, 27 power negative, or to get rid of the negative first, sorry, we flip the entire fraction straight away. So it's 64y power 3 over 27 x power 12 to the power of 1 over 3. Then from there, we will multiply the powers. So it's 64 power 1 over 3, y to the power of 1, 27 to the power of 1 over 3, x to the power of 4. So from here, power of 1 over 3 means this is cube root, and this is cube root as well. So cube root of 64 is 4y, and cube root of 27 is 3x power 4. And that's our final answer. You are not allowed to leave it in fractional index, so please calculate out the value fully. So for question number 3, it is a transformation question. So for this transformation, we have on the grid, draw the image of triangle A after translation by the vector -3, 2. So this translation is -3, 2, where the top number is the horizontal and the bottom number is the vertical. So in this case, we are looking at essentially what is the symbols. If it's a -3 for the horizontal, means we move to the left by 3. So we take one tip here, 1, 2, 3. And then the vertical, it goes up by 2. So we're going to go up by 2 as well. So it's 1, 2. Now, after you plot one point, actually, you don't have to do all the other points. You just need to recreate the shape because end of the day is a translation. So translation means size doesn't change. You're just changing the position of the shape. So you just need to draw the exact same thing. And then we label this as A prime. If they never tell us what to label, usually we label A prime or you just put the answer A1, right? For the question number itself, right? So this will apply for the next following questions. So in A2, what they ask us is triangle A after a reflection in the line y equals to x. So the line y equals to x is the most one of the most fundamental straight lines you're given. Y equals to x is like x equals 1, y equals 1, x equals 2, y equals 2, and so on and so forth. So it's basically us drawing this line cuts through the diagonal like this, right? So from here, we call this y equals to x, and then we draw our transformation. So it is just a reflective shape, so just draw exactly as the reflection shows. So, oops. So this would be our answer. I think I drew that a bit too far. 3 boxes, 2 boxes diagonal, 1, 2. Right, so you can see that it's a nice reflection here. So this is A prime prime, or I can just call this as A part 2 lah. Right, you can just label the question if you would like, right? That will be easier. So describe fully the single transformation that maps the triangle A onto B. So now we are transforming A to B itself. So A to B by itself, you can see that the orientation has changed. Now, how we know the orientation has changed is because you see the side here, this is 3 boxes long. The 3 boxes long is now facing upwards, and now this corner here, this corner tip up here that's opposite the 3 boxes is now facing towards the left. So we can conclude that the shape has rotated like this, right? It has made a turn, right? So this turn is 90 degrees. How I know is because, like I said, the 3 boxes flat, now it's 3 boxes standing. So flat to standing is a 90-degree turn. So first of all, we can say it is a rotation, and we know the direction, 90 degrees. Turning to the left is anti-clockwise, right? In the reverse clock manner. So the next thing we need to look at is the center. So as I've mentioned previously before, you can eyeball the center. So we usually just put one testing point. So let's just take a testing point, probably somewhere around, maybe around, that's a bit far, probably around, oh, that's a bit far as well, maybe around here. Oh no, this one is the wrong orientation. So probably around here. So if we take this point of reference, yeah, I think it's easier to take these points of reference instead. So I think we look at this tip, and this tip is much easier. Then we can see the rotation, how the rotation goes. Yeah, so it seems like it's around here actually. This rotation, Yeah, I think, yeah. It is probably somewhere around here. Yeah, actually, I was right the first time already like this. Right, so we can see that the 90 degree is formed from here already. Sorry, I also misinterpreted the line. So this is a 90-degree rotation because we can see that it turns like this. Right. So in other words, our center of rotation would be 1, -1. So this is 1, -1. Right. And then as for question C, we are not going to look at the question because question C is not part of the syllabus anymore. We no longer do matrices in this question. Right. So we move on to question number 4. So moving on to question number 4, we have diagram shows a hemispherical bowl, radius 5.6, cylindrical tin of height 10. Show that the volume of the bowl is 368, correct to three significant figures. So all we need to do is just plug in our formula. 4 over 3 pi r cubed is equals to 4 over 3 pi times 5.6 cubed. This is a hemisphere, however, so it is going to divide by 2 because this is half a sphere. It is not a full sphere, yeah? So 4 over 3 pi r cubed and then divide by 2. So that would be 368, correct to three significant figures. This is shown, yeah? Right. So the tin is completely full of soup. When all the soup is poured into the empty bowl, 80% of the bowl is filled. Find the radius of the tin. So in other words, this volume of the bowl filled, it is 80% of the cylinder. So we can say that the volume of cylinder is essentially 80% or 0.8 times of the bowl, 368, correct to three significant figures. You may use the answer from above because that's usually how the IG questions work. We work from the question above. So the volume of the cylinder is 294.4. So from here, volume of cylinder is pi r squared h equals to 294.4. We know the height as 10, but we do not know what's the radius, so we can work towards our answer. So from here, pi r squared equals to 29.44. And then we have r squared equals to 29.44 over pi. And lastly, we square root both sides. R equals to square root of 29.44 divided by pi. So that is square root of 29.44 over pi. So that is 3.06, correct to three significant figures for our radius. So in question B, so they ask us to calculate the total surface area of the cone. So as for the total surface area of the cone, we are looking at the curved part and the bottom part, yeah? So we can assume that this is floating in space. It's not really on the ground anywhere, yeah? So from here, we are looking at the total state. Gave us the curved surface area pi RL, but we also need to consider the circular part as well. Now, before we do our pi RL, L is basically the slant or this corner here on the side. So we need to identify what this is first. So we call this as L. So in other words, L equals to Pythagoras theorem. This is going to be 6, and this makes a 90 degree with 1.75. So that is a right angle triangle. So L will be 6 square plus 1.75 square to calculate the L. You may leave it in cert if possible. If not, you can leave it in, actually it's possible. So this is 25 over 4, right? Quite a good number. So from here, our total surface area would simply be using our formula pi RL plus our circle at the bottom pi R square. So I'm just going to extract, actually, never mind, I'll just plug in the value straight away. So it'll be pi, so R is 1.75, L is 25 over 4, plus pi, our radius is 1.75, whole thing squared. So we can just do calculator work from here already, not much to consider, not much else to consider. And that would be 14 pi, or to simplify, it would be 44.0 in three significant figures, cm square, right? So that is for B. So in B part 2, in part 2 itself, we have the cone filled up to a certain degree. So the cone contains salt to a depth of 4.5 cm. The top layer of the salt forms a circle parallel to the base of the cone. So show that the volume of the salt inside the cone is 18.9 cm cubed, correct to one decimal place. So we can consider this to be 4.5, and then we also can still consider this full height as part of the previous question. So previous question, the height given to us is 6. Now, why am I interested in the height of the previous question? This is 6. Now, if you focus in this part here, we don't have enough dimensions to calculate the empty space on the top. There's still a cone, but you notice that if I draw this triangle here and I draw a dotted line up here for the radius, right? You notice that if I extract out the shape, it is a triangle right angle triangle inside another right angle triangle here. So we can develop a ratio for this case. So they are supposed to be mathematically similar because they said that this circle is parallel to the base of the cone. So this is parallel to this section. So it is a similar shape. So in other words, if this is 1.75, this is 4.5, this whole thing is still 6 as well. And then this small part here is 1.5 lah. So we can make a ratio for the big triangle, which I will now color it in red, to the small triangle, which I'll retain as the green, but unfortunately it's taking up quite a bit lah. So I'm just going to draw a second layer of color here just to indicate what I'm talking about. Right, so this is a second layer. So let's see. So the height of the big triangle over the base of the big triangle should be equivalent, have a same ratio with the height of the small triangle over the base of the small triangle. So the height of the big triangle is 6. The base of the big triangle is 1.75, whereas the height of the small triangle is 1.5. We do not know what's the base of the small triangle, or in other words, the radius of the small triangle. So we can do calculation for this. So 6 divided by 1.75 would be 24 over 7 equals to 1.5 small base, and then we can swap the small base with the 24 over 7. And we can calculate. So 1.5 divided by 24 over 7, and that will give us 7 over 16. Right, so this is the radius of our small cone. So from here, we can count the volume of small cone. In this case would be 1 over 3 pi r square h, where our r is what we have calculated earlier, 7 over 16 square, and our height is 1.5 for what we calculated as well. So 1 over 3. We are going to leave our answer to one decimal place, yeah? But before that, we need to perform all of our calculations first before we consider that. So that would be 0.3 cm cubed to quite a high degree of accuracy. So the volume of the big cone in this case would be the same thing, 1 over 3 pi r square h. So that would be 1 over 3 pi. Our radius is 1.75 square and our height is 6. So from here would be 1 over 3 pi 1.7 square h. So that is 49 over 8 pi. So from there, our salt in the cone is 49 over 8 pi minus 0.3. So 49 over 8 minus 0.3 would be 18.9 cm cubed, correct to 3 significant figures. So this is shown according to the question. So that's part B2, B2A done. It is kind of a bit weird, right? So moving on to our next one. So our next one, the salt is removed at a constant rate of 200 millimeter cube per second. So calculate the time taken for the cone to be completely empty. Give your answer in terms to the nearest second. So we know that the volume is 18.9 cm cube. So we need to convert it to millimeter cube now. So cm cube to millimeter cube. First, we look at cm to millimeter. It is a multiply by 10. So a cm cube to millimeter cube has to be multiplied by 10 cube, right? Doing it 3 times. So from here, 18.9 multiplied by 10 cube would simply be 18.9 times 10 to the power of 3, which is 18,900 millimeter cube, right? And then it goes out at a rate of 200 millimeters cube per second. So all we need to do is just take 18,900 millimeter cube divide by 200. So this is the time taken. And we know the answer will be in second because this is millimeter cube per second. So 18,900 divided by 200, that will give us 94.5 seconds. And they want the answer to the nearest second. So it's 95 seconds. So this is, although it's in 2 significant figures, it is the answer that they want because they want us to write into the nearest second, not the nearest millisecond. Yeah. Decimal for seconds is millisecond. So in this question here, unfortunately, the question here has a very, very big graph, so I am not able to do it to the best degree of accuracy, but I will try my best. Right, so you would have to refer to your own graph in this case just to make it better. I can show you the working and all for it. I may not be able to generate the correct values for it. However, there is an answer sheet that will be provided to you, so you can refer to the answer for the values. For this, I'll just show you how to calculate the values. So in this case, in question A1, we have F1. F1 is simply just When x equals to 1, what is f? So here, our equation is fx and so on and so forth. So when we put f1, what they're trying to say is that when x equals to 1. So when x equals to 1, all we have here is just x equals to 1 is simply drawing a direct vertical line that cuts through 1 like this. And then the intersection point here is your answer, right, in this case. So the next one in part 2 is f negative 2. So what is f negative 2? So first we need to draw f negative 2 itself. So f negative 2 is somewhere around here. Now, after you draw f negative 2 already, you need to identify what the answer is here, right? Let's assume the answer here, we are going to get some value here. It's kind of like 3 or 2 or something like that. So in other words, f negative 2, the inside portion, which is f negative 2, will provide us of a value of somewhere around 3. So we need to use the graph one more time, which I'll do in green color to do f3 again. So now we have to do x equals to 3, and then we have to do like that. Now I say 3 is not really 3, because I can't see the graph very well, but use the value that you are given when you calculate. And then after you do that, we are going to extrapolate to find the y value. So in this case, I found 6. But of course, this is not a fully accurate answer. Please attempt it on your own. This is just the working, right? So for the next part, on the grid opposite, draw a suitable straight line to solve this equation. Now, in order to solve any equation for this kind of graph equation, right, it is always based on your original graph equation. So first of all, we will look at the original graph equation, which is fx x squared minus 2 over x minus 2, right? So the question is giving you x squared minus 2 over x minus 7 equals negative 3x. You need to match this left side as best as you can. So what you can do is that this is 7 over x here, right? Minus 7. Couple of values you need to alter. So first of all, in order to make it a little bit easier, so what you can do is that you may consider if it's hard to count, you can first multiply actually it is x squared minus 2x, the only value that doesn't change this, sorry. So all you need to do is just add 5 on both sides. So when we add 5 on both sides, x squared minus 2 over x minus 2 equals to negative 3x plus 5. And this is the curve equation already. In other words, y equals to negative 3 plus 5, or in this case, fx equals to negative 3x plus 5. And this is the line that you need to draw. So all you need to do is just draw. So we are going to take x equals to negative 3 and x equals to 3 because that's the domain they provided. So x equals negative 3 will give us fx equals to negative 9 plus 5, positive 9 plus 5 really in this case. So it's 14. There's no value for 14, so you can't use that. So let's use something smaller instead. We have a y-intercept already, which is 5. So straight away, we have one value here to work with. I will do it in red color. So in red, this one is 5. Right? And then another value that you can use, let's say x equals to 1. So fx equals to negative 3 plus 5, and then fx equals to 2. So since fx equals to 2, x equals to 1, value is somewhere around here. It's a thing that's going down, yeah? So all you need to do is just use a straight line and use a straight ruler, long ruler, and connect the two coordinates together. So all you can see here is that the places that intersect with the curve is your answer in this case. So I should just circle in red to match the color code of the question, yeah? So these will be your solutions. You just need to check back with the x values, right? Because they're asking for what value of x does this occur. So you need to extrapolate back into your graph the values of x that you see, right? So that is in part C. So far it's a little bit messy. So I will redo the graph. So the next portion of the question, they ask us to, by drawing a suitable tangent, find an estimate for the gradient of the curve at x equals negative 2. So at x equals negative 2, what you need to do is that you need to check the curve. So where is the curve point at x equals negative 2? So by zooming in a little bit more, x equals to negative 2 is somewhere around here. So what you're going to do is that you're going to draw a tangent line. So draw it to the best degree of accuracy as you can. There's no ruler in here, so I can't really do it as well, but I'll show you the method. So let's say you try to draw as close as possible to the curve, but only touch that point ngam there, right? Just nice. So what you're going to do is that you're going to take any two coordinates from this drawing. So in this case, I will take the easy value. You cannot use 2 again, yeah? You need to use something else that's on the line. So in my case, I will use this value here because this one looks a bit nicer. So according to the boxes 1, 2, 3, 4, this is my 10, yeah. So this is the yeah, it seems about like 1 and negative 0.4, or I should say negative 0.8 because every box is negative zero point 0.2, yeah. So it's negative 0.8. And then another point up here. So maybe I choose a point that is like 1, 2, 3, 4, 5, 6, 7. Yeah, it's about 10. So I'll take around here lah, right? So this one would be 8987. So this x coordinate is negative 2.7, whereas the y coordinate need to extrapolate a little bit more. So that would be 4.2468 lah. So 4.8. So once you select any two coordinates that are of your choice, so you can find the gradient. So the gradient is simply just the normal calculation, y difference over x difference. So in this case, it would be negative 0.8 minus 4.8 over 1 minus negative 2.7. So once again, you may not get the same values as I do because I'm not drawing it exactly to scale as you are. Please do it exactly to scale as you can see in your question there. So you should get a better answer than mine in that sense, right? So from here, the next one we will have is the question D1. So question D1 is just calculator work. Complete the table for all the values of y equals to gx, where gx equals 2 power negative x. So all we need to do is just plug in a calculator, the values. So it's 2 power negative 3, 2 power negative negative 3 would simply be 2 power 3 lah. So that would be 8. And then 2 power negative negative 2 would be just 4, 2, 1, 0, and then 2 power negative 2 will be 0.25, 0.125. So that's it. So on the grid opposite, draw the graph. I'll leave that to you. And then use your graph to find the positive solution to the equation fx equals to gx. So after you draw your graph already, right? Presumably, what will happen in your graph is that this graph will intersect here lah somewhere. So I'll just try to draw a rough value, a rough one, because I can't really get it to a very high degree of accuracy. So negative 3.8 is somewhere around here. And then negative 2.4 is somewhere around here. Negative 1.2 is somewhere around here. 0.1 is somewhere around here. 0.5 is somewhere around here. 0.25 is somewhere around here, and so on. So, and also the last point 3, 0.125 is somewhere around here. It's very close lah. So you're going to draw something like this, and you notice that this line cuts both graphs. So in this case, this is the negative solution. This will be the positive solution. So your answer is here. So we get x equals to something here, right? So you may refer back to your own graph. As for my accuracy won't be as high lah, as I mentioned multiple times in this question already. So moving on to question number 6a. So on question 6a, what we'll have here is another question on estimation of mean. So estimation of mean works with midpoint first. So to get our midpoints, this is just add them together and divide by 2. So this is 20, 25, 32.5, 37.5, 50, and lastly 80. So our mean would simply be a multiplication, which is 25 multiplied by 38, 32.5 multiplied by 27, 37.5 multiplied by 21, 50 multiplied by 16, 80 multiplied by 18. Whole thing is going to divide by our total frequency. Don't need to add them together because the total already is 120 in the question. So all we need to do is just work with our calculators from here. So I will just type it down as well. So it is a good habit for you to total up the value here, 4855 on the top over 120. So when you double check your answer, it's easier for you to double check. So this is 40.5, correct to 3 significant figures. Right, so this is question number 6a, complete. And then for 6b, they ask us to convert this frequency diagram into a frequency density diagram. So frequency density is merely a calculation of FD equals to frequency over class width, right? So all we need to do is just, they already did the first bar for us. We need to count for the rest of the 4 bars. So for 30 to 35, FD equals to 27 over 5. The class width is 5. So 27 divided by 5 is 5.4. Next is 35 to 40. Again, the class width is 5. Frequency is 21. So 21 divided by 5. So 21 divided by 5 is 4.2. Next class is 40 to 60. So again, frequency density equals to 16 over class width is 20 this time. So 16 divided by 20 would simply be 0.8. And then for our last frequency density, FD equals to, for 60 to 100, this would be 18 over 40. Our class width is 40. So then from here, this will be 0.45. And then now we can plot our values. So we will have 30 to 35 at 5.4. So 30 to 35 at 5.4 would be simplified to somewhere around here, as best as I can see. So as for the calculations are correct. It's just that maybe for my graph drawing, I may not be as accurate. So I trust that you guys will be more accurate than I am, right, in this case. So 35 to 40 would be 4.2. So 4.2 is probably somewhere around here. And then you will have 40 to 60 at 0.8. 40 to 60 at 0.8 is somewhere around here. And then the last one is 0.45, which is 60 to 100. Somewhere around here, right? So this is the rough shape it should look like, but your value should be precise, yeah? So as for my graph, a bit difficult this time around because the graph is generally a bit smaller. It's not like the previous videos where I could actually draw. The graph is not that bad. This time around, the graph is a little bit pixelated, so I can't really draw to a good degree of accuracy. So moving on to 7. Straight line joins -2, -3, 1, 9. Find the equation of the line. So we have gradient equals to y2 minus y1, x2 minus x1. So we will just take our perspective. I start from 9. So 9 minus -3, whole thing divided by 1 minus -2. So that's 12 over 3, which is 4. So we have our gradient, y equals to 4x plus c. So we can plug in any coordinate. I like to plug in the simpler one, x equals to 1, y equals to 9. So 9 equals to 4 times 1 plus c. C equals to 5. So therefore, y equals to 4x plus 5. This is our straight line equation for question A. Moving on to question B, find the acute angle between AC and the y-axis and the x-axis. Now, AC is a length, like this. AC is a length. Now, if you were to draw it to a scale, right, that means like rough estimation, don't need to be so precise. So in this sense, -2, -3 is probably somewhere around down here, right? Somewhere down here, right? And then 19 is somewhere up here, right? So what they're asking us, this line, what is the angle it's making with the x-axis, as in, what is it? What is the angle here, basically? So we know that this is 19 already. So in other words, this height here is 9. And then this part to this part here, we need to identify. We know that this is 1, but we do not know what is this. So according to our graph, right, we can actually calculate when y equals to 0. So 0 equals to 4x plus 5. So we know that 4x equals to -5 and x equals to -0.8. So this is -0.8. So this distance from here to here is 1.8, yeah, because 1 for the x positive x and 0.8 for the -1. So this one is 1.8. So from there, we can use tangent to calculate. So tangent theta equals to opposite over adjacent. We call this as theta. So opposite is 9. Theta, adjacent is 1.8. So theta would simply be shift tangent of 9 over 1.8. So that would simply give us 78.7 degrees, right? To 3 significant figures, right? So the next one would be C. So ABCD is a kite where AC is the longer diagonal of the kite. B is the point, 3.52. So they have provided us a kite already. So sorry, it's a diamond, so I can't really say it like that. So this is as it's not a very good kite, I must say as well, but it's basically something like this, lah. Right. So the longer diagonal is AC. So it's AC. So I assume B and D is here, lah, because we need to go in like a certain order. So we know that B is 3.52. We also know that A is -2, -3, C is 19, and D is unknown. At the moment, we don't know what's this. We call this XY. So we notice in any kite, right, no matter how you draw the orientation, right, this diagonal and this diagonal, right, always make a 90 degree no matter what. So if they ask us to find the equation of line BD in the question, right, in other words, we already did AC earlier with our equation, which is y equals to 3x plus 5, y equals to 3x. I need to check back the value. Sorry, y equals to 4x plus 5. So y equals to 4x plus 5. Now, since this is y equals to 4x plus 5 previously, we know that we can infer that MBD times MAC is equals to -1. So to find MBD, MBD times by 4 equals to -1. Therefore, MBD equals to -1 over 4. So the equation now is y equals to -1 over 4x plus c. So when x equals to 3.5, y equals to 2. So 2 equals to -1 over 4 multiplied by 3.5 plus c. So 2 equals to 0.875. And then find negative, and then c would simply be 23 over 8. So from here, y equals to -quarter x plus 23 over 8. So that is our line equation for BD. So working from our line equation for BD, we have the diagonals AC and BD intersecting at a certain coordinate here. So from here, for our intersection point, we know that the diagonals AC and BD intersect here, -0.05, or I would just highlight here. This is -0.5 and 3. So this portion here is the midpoint for BD, right? So we can work the coordinates of B. So in the other words, it's 3.5 plus x divided by 2 equals to -0.5, whereas the other one is 2 plus y over 2 equals to 3. So we have 3.5 plus x equals to -1, x equals to -4.5, whereas the y, 2 plus y equals to 6, so y equals to 4. Therefore, our coordinate is -4.5, 4. So that's done for the next portion, right? And that is the full analysis of our height question really. So that is finally done for question number 7, right? It's long, but it is quite normal for paper 4 questions that they will take part after part after part in that sense. So for number 8A, Angelo has a bag containing 3 white counters and X black counters. He takes 2 counters at random from the bag without replacement. Without replacement means he takes it out, he doesn't put it back. So complete the following statement. The probability that Angelo takes 2 black counters is x over x plus 3 times x minus 1, because he take away 1 black counter already. And now the total also dropped by 1, so x minus 1 over x plus 2. So the probability is given to us as 7/15. Show this. So we've already calculated the probability above. In other words, x over x plus 3 multiplied by x minus 1 over x plus 2 equals to 7/15. So let's take our time to multiply. So we multiply the top by itself is x minus 1, x plus 3, x minus x plus 2 first, like this. Now I'm not multiplying it yet because I'm trying to get rid of all the fractions first if possible. So this will be 15x, x minus 1 with the cross multiply, 7, x plus 3, x plus 2. This one should be your basics, yeah? Now we expand the bracket, 15x squared minus 15x equals to, don't multiply the 7 in first, multiply the simple one first, x squared plus 2x plus 3x plus 6. So that is 15x squared minus 15x equals to 7, x squared plus 5x plus 6. And then we multiply the 7 into the bracket. So it's 15x squared minus 15x equals to 7x squared plus 35x plus 42. Move everything to the left side. So we will end up with 8x squared minus 50x minus 42 equals to 0. So divide everything by 2. 4x squared minus 25x minus 21 equals to 0. This is shown, right? And this is done for part A. Part B is solved by factorization. So solve by factorization means that we need to write the answer in the double bracket form. So once again, we may use our cross method, or if no cross method, you can reverse calculate, which I will show in a short while. So from here, we can work with, let's say, test a few values, 4x and 1x. And then another test value we can try is probably -7 and +3. So we draw the cross. So multiply along the cross, we get -28x. This will also be +3x. So 3x minus 28x will be -25x. And this value is the same as this value. So in other words, the answer would be here, followed by here. This is the cross method, yeah? So From there, it's going to grab all of this. So it is 4x plus 3, x minus 7 equals to 0. So it's double solving for both brackets. 4x plus 3 equals to 0, x minus 7 equals to 0. So x equals negative 3 over 4, x equals to 7 in this case. Now, if you want to reverse calculate on your calculator, also can, but be careful. This will not consider for factorization, yeah? So if you get your answer on calculator, x equals negative 3 over 4 and x equals 7, all you need to do is just reverse your steps. So it'd be 4x equals negative 3, 4x plus 3 equals 0, and this will be x minus 7 equals to 0. So these two will serve as your double bracket. So make sure you write it in the reverse order if you want to do it in the reverse way. So this is also acceptable in this sense, right? So you may choose the method that you would like to use. So lastly, for part C, they ask us to write down the number of black counters in the back. So basically choose the x value. So of course, we can't have fraction for our for number of balls. So in this case, we will take x equals to 7 in this case. So there are 7 black counters in the back, right? That is our x. And then in part B, so Esme has a bag with 5 green counters, 4 red counters. So this is a different situation again. She takes 3 counters without replacement. Find the probability that all the counters are the same color. So there are 2 cases here. It's either green, 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 or red, red, red. So to count green, 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 probability would simply be 5 over 9 times 4 over 8 times 3 over 7. Whereas for red, 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 probability would simply be 4 over 9 times 3 over 8 times by 2 over 7. And we can calculate all these values here already. So this would be 5 over 42. Whereas for the bottom calculation, this would be 1 over 21. So when we add them both together, so this would simply be 1 over 6. So that is our total probability for when they select both same colors. So for question number 9, so we have another triangle to work with. So BC is a vertical wall standing on the ground, angle of elevation of C from A. So C from A means starting from A here, looking upwards towards C. Angle of elevation is 26 degrees, whereas the angle of elevation of C from B is 72. So I can label this as 72 degrees. So show that AC is 76.7, correct to 1 decimal place. So we are given a couple of values to work with already to start. So our first thing that we can consider is we have our trigo. So according to our trigo, we have the ratio 58. So we can say that tangent 72 equals to opposite, which is CB, over adjacent. I'm just going to call this X for now. So this is DB lah, right? Which is X. So tangent 72, I call this H. I call this H and X lah. So tangent 72 equals to H over X. Now, another one that we can look at is tangent 26. So tangent 26 is going to be H over, opposite over adjacent as well. So it's H over 58 plus X in this case. So these are values. Now, if you multiply it across, so X tangent 72 equals to H, whereas 58 plus X whole thing multiplied by tangent 26 equals to H, right? So we have two equations here. This is equation 1 and this is equation 2. So I can say equation 1 equals to equation 2 because I am making H the subject in both situations. So X tangent 72 equals to 58 plus X tangent 26, right? And then from there, I can actually start to calculate already. So tangent 72, if I take a few more decimals, 3.078x equals to 58 times tangent 26 would be 28.288 plus 0.4877. So we have x, yeah. So we can solve. So we minus both sides by 0.4877. So 3.078 minus 0.4877. That will give us 2.5903x equals to 28.288. So x equals to x equals to 10.920. So since x equals to 10.920, so then from here we can calculate our BC. So our BC would simply be, or our H lah. So our H would simply be 10.92 multiplied by tangent 72. So you can use either equation 2 or equation 1, right? You'll get the same answer, yeah? So I use equation 2 because it's easier. So 10.92 times tangent 72. So that will give me 33.608. So from here, I know that this whole stretch is 58 plus 10.92, whereas this upper stretch is 33.608. So I can use Pythagoras theorem to prove it. So from here, 58 plus, so this would be 68.92 square plus 33.608 square. And then we square root to find our AC. And then we will get 76.7 correct to 1 dp. This is shown, right? So we can obtain these values immediately to calculate for our part 1. So in part 2, well, actually, yeah, in part 2, actually, I've done part 2 already. So this, you can just rewrite the working. Part 2 and part 1 actually have, I think in part 1, they may not want you to count the BD per se. So if you want an alternative working for this, so that means without actually finding the BD, right? It's actually possible to do. It's just that this came first in my head. If we don't want to do it like that, we can do it like this instead. We can find the angles here. So this angle here is 180 minus 90 minus 72. So that would be 18 degrees. So since it is 18 degrees, we can find out what is this portion as well. I will do it in green, this portion here. So this portion here would be 180 minus 26 minus 90 minus 18. So that tiny portion there would be 46 degrees. So since this is 46 degrees, so if we take out the triangle from here, you'll notice that we have a triangle like this. This one is 26, this one is 46, and then we also know that this one is, this stretch is 58. Of course, I didn't draw it very nicely, so apologize for that. So from here, we will also know that this angle here is 180 minus 46 minus 26, which is 108 degrees. Actually, I could have counted 108 much faster, but this, I'm just counting all the angles to see what I have. Now we can work with the sine rule pairs. So we can pair this and pair this together. So it will be 58 over sine 46 equals to AC over sine 108. So we can just multiply straight away. 58 over sine 46 multiplied by sine 108. So even with this method also, we still get the same answer. It will be 76.7 correct to 1 dp. This one is shown as well. So you may use either one of the methods, but if you want to like make it cohesive, then I would recommend you to just work with the this method first, and then for part 2, use the first method that I showed you earlier. Right? You may rewind the video to have a look at it. So from here, in question B, so triangle EFG has an area of 70 meters square. I think I will not remove the triangle first. So I will just work with the oh, this is a different triangle already. Sorry, that's fine. So EFFG is 1:2 ratio. So angle EFG is 40 degrees. So find EF. So this EF to FG is the ratio of their lengths. So angle EFG is 40 degrees. So it is just a pretend triangle, lah, right? So something like that. So this is E. They say EFG is 40 degrees, yeah? So I'm just gonna pretend that the E height is E, and then F, and then G, and this is 40 degrees, right? And then they gave us the ratio of, this one is 1:2. EF to FG is 1:2 parts, lah, right? So they asked us to calculate out what is the length of the triangle based on our ratio. So according to our ratio, we have angles here. So from there, so I guess assuming that this is a 1:2 ratio, so I'm gonna just pretend that this is x and this is 2x lah, right? Per se. And then when we go down from here, we can find this height lah. So we can calculate out the height based on a Pythagoras theorem as well. So from here, if I pretend that this is x, and then I pretend this is 40 degrees, I can actually find out what is this height. So the height in this case is sine 40 equals to opposite over hypotenuse, which is sine 40 equals to h over x. So I can swap the positions. X equals, oh sorry, I want to find for height. So height is simply x sine 40, right? So that is the height in this case, x sine 40. So I can use this as my height. I can use this as my base. So therefore, I will take 1 over 2 times height times base equals to 70 meters square. So from there, height multiplied by x sine 40 multiplied again by 2x equals to 70. And then I will cancel out the half and the 2 here. So x squared sine 40 equals to 70. And then I can recalculate x squared equals to 70 over sine 40. X equals to square root of 70 over sine 40. So from there, I will get 10.44 cm, right? So my EF ultimately is 10.44 cm. That's my X, right? Or it is 10.4 cm, correct to three significant figures. So part 2, a different triangle, PQR, also has an area of 70 meters square. PQ ratio QR is 1 to 2. PQ equals to EF. So that's from our last question. So now, they ask us to calculate the angle of PQR. So again, it is a different triangle. However, they told us that PQ equals to EF in the sense of this is also going to be 10.4. So this is P, Q, and R. And now they ask us to calculate the angle of PQR. This angle here. So PQ ratio QR is again 1 to 2. Yeah, so this is one part, this is two parts. So that means if PQ is 10.4, PQR is 20.8. Right? So actually, yeah, actually, if it's a different triangle, yeah, so if it's a different triangle instead, we could actually consider a different angle for PQR. PQR itself, I guess in this sense, they are asking us to redraw a different version, a different variation of this. So a different variation of this is that I can call this as 40, right? But another value, if you remember in trigo, right? Sine 40, sine is positive for 40 degrees. So the other angle is in quadrant 2 for this one. So in quadrant 2, sine 40 is equivalent to sine 180 minus 40, which is basically sine 140 degrees. So 140 degrees would be the angle of the triangle that I'm going to draw. So how the triangle will look like, right, is that the triangle will basically look like this. Instead of working out the ratio like that, right, PQR could look like this. So the angle PQR will be like that. So that means PQ is here, and then R is here. So this is 1 and this is 2. That means this is the longer part. This is the it's kind of like spread out a little bit. So it's kind of like this and like this. So, and then I get like that. So you see, this is a different triangle, PQQR. So this is 10.4. This will be 20.8. And now the angle here is 140 degrees. We can have a triangle like this as well as an alternative. Right, so that's for B part 2. So for our final few questions, starting from question number 10A. So for question number 10A, we have write down the next two terms of the sequence. So from here, 19 to 15 is minus 4, 15 to 11 minus 4 again. So if you minus 4 one more time, that would be 3. And if you minus 4 from that, you will get negative 1. right? So find the n term of the sequence. You may use your formula Tn equals to a plus n minus 1d. So you know our first term is 19, and we know our pattern is -4. Common difference is -4. So Tn equals to 19 plus n minus 1 multiplied by -4. So 19 plus or minus 4n plus 4. In this case, it will be 23 minus 4n. So that is our nth term. If you don't want to do this, you may also use the shortcut that I taught you. So Tn equals to a plus bn, where bn plus an plus b. So a is just the pattern, and b is the first term minus the pattern. So then it will be -4n plus 19 minus -4. So again, see, you get the same answer, -4n plus 23, same thing, right? Or part 2. So for part 3, they say find the value of the n when n term is -65. So Tn equals -65. So we're going to reverse calculate 23 minus 4n equals to -65. -4n equals to -88. Therefore, n equals 22. So this is given already straight away. And the next question is part B. So another sequence has nth term 2n squared plus 5n minus 15. Find the difference between the fourth and fifth term. So we have P4 as 2 4 squared plus 5 times 4 minus 15. So this is just a calculation-based question. So it's 37. Whereas T5 would be 2 times 5 squared plus 5 times 5 minus 15. So that would be 60. So in other words, T5 minus T4 would simply be 60 minus 37. So that's 23, right? So that is our difference between the terms. So, oh, that's about it. Right. So that's about all for the questions. So good luck for your trial exam, and also good luck for your preparation for the math paper. I'll see you guys soon.